In his play Life of Galileo, Bertolt Brecht presents us with the dilemma of a mathematician whom Galileo went to see. He presented him with a telescope of his invention with which you could look at stars. These stars, however, were deemed impossible by the knowledge of that time. They were not supposed to exist. The mathematician thus responded that the telescope, showing something impossible, was unreliable. Of course, this might indeed have been the case. Showing something that contradicts the knowledge of the time, the telescope should have been warranted further scrutiny. But to directly reject the validity of what the telescope sees, only because of its unlikelihood, is akin to rejecting any new thoughts. Nowadays, it would be unthinkable to reason this way in modern, evidence-based science. Would it? Hello, this is Quentin Bammey. I'm going to talk to you about our work in image forensics, in particular about the trace database that enables a precise evaluation of image forgery detection methods based on their reaction to different traces. This work is funded by the Direction Générale de l'Armement and Région Île-de-France. In image forensics, one wants to detect image forgeries. In other words, given an image, we want to know whether it is authentic, and if not, to localize which region of the image has been tampered with. Nowadays, CNN-based algorithms are trained on large databases of image forgeries to detect and localize each specific forgery. These supervised networks can of course yield excellent scores on benchmark datasets, especially when trained on similar forgeries from the same dataset. However, what can we say of their practical usability? Assume that in the training database, flags in images are always forged. On the other hand, our flowers are authentic. Can we be sure that the network won't just detect our flags as forgeries and we think our flowers are authentic? Indeed, this would be akin to the previous situation with a telescope. Unfortunately, this kind of bias is difficult to completely eliminate in forgery datasets. What we can do, however, is test whether a forensic tool can detect forgeries for reasons other than semantics. These forgeries can usually be detected as inconsistencies in the trace of the image. What does that mean? Let's start from a camera taking a photography. From its birth in the camera sensors to its storage in a compressed format, the image will go through different steps. Each of these affects the noise of the image in a specific way. As a consequence, as the image goes through different steps, this noise is affected as well, and the final noise curve is very different than on the raw image. Furthermore, because each camera is different, its processing is different as well and will imprint specific traces onto the image. Post-processing with photo editing software will further alter these traces. As a consequence, if part of an image is modified or if a region is spliced from one image to another, the forged region will feature inconsistent traces with the rest of the image. This inconsistency is what can be detected by forensic tools to evidence the presence of a forgery. A question now arises: how can we evaluate the ability of a forensic tool to detect forgeries based on these traces without letting it make semantic detections? Indeed, every time you add a forgery on an image, you not only add the traces of the forgery, but also create grounds for a semantic detection. Our proposed answer is simple: add the traces of a forgery without adding the forgery itself. Take one raw image, process it with two different pipelines, then create a mask and merge the images according to that mask. Use the image processed with the first pipeline inside the mask and the image processed with the second pipeline outside of it. What you have just created is not a true forgery. Its semantic value is still the same as the original image. Nevertheless, it contains the traces of a forgery, and we can thus use it to evaluate forensic tools. The proposed approach can be used to know if a forgery detection method can make trace-based detections beyond semantic detections. Not only that, we have full control over the processing pipelines and can vary one specific parameter between the two pipelines, which enables us to know how sensitive each forensic tool is to different kinds of inconsistency and lets us know their synergies.